In theory, this is all review, but I'm going to go way faster. What you did in about 2 or 3 weeks last year, I'm going to do in 1 day. So if it seems like I'm going fast, I am. We're trying to brush the cobwebs off. Velocity, acceleration, and displacement. Acceleration. This is defined as a change in velocity over a change in time interval. In math notation, we write this. It's a vector, so I'll put the vector sign above it. Change in velocity over, don't write this next bit down, just watch for a second. It's a change in time, but because time is always a change in, over the years we've gotten sloppy and just stopped writing the triangle in front of it because it's always a change in, so we get lazy that way. And one of the things that's worth memorizing this year is that change in anything is always final minus initial. We can also write it like this. Final minus initial. This is not how it appears on your formulas page. On your formulas page, Tyler, what we're going to do is we're going to get the VF by itself. What you see on your formulas page is this one. VF equals VI plus AT. Well, no, you don't quite. I think on your formula sheet they don't use VF and VI. I think they use V as VF and V naught or V0, right? Same idea. I use VI and VF myself, and I'll rarely say V0. My high school physics teacher was one of my heroes, and he was British, and so for him it wasn't a 0, it was a naught, and so it was always V naught, and so his honor, I'll probably use that expression. And also, it sounds nerdier, so I'm good. Little note, this assumes uniform or unchanging acceleration. If you have a changing acceleration, it gets a little ugly. In fact, you need calculus. In fact, those of you that take physics next year, probably one of the first things you'll look at once you've learned some calculus. A lot of the time your physics profs will teach you some quick and dirty, easy calculus tricks just to get you started. And then you'll, now we can finally have a changing acceleration. When would you have a changing acceleration? Rocket ships. Because for a rocket ship, you have a constant thrust, but as the fuel burns, what happens to the mass? Gets smaller, but the same force, which means if you have the same force but mass is decreasing, A has to increase. So I can't do good, proper rocket science without calculus. If we have uniform acceleration, we can find average speed, written, I tend to write it as V-average, but the symbol for average is a horizontal bar. Well, oh, sorry, that's not a vector sign, Mr. Dueck, just a bar. The average of anything is, Colin, if you have 10 bucks and I got 20 bucks, what do we average between us?
15.
How do you calculate that? Add them up.
And divide them by how many there are.
I think that's the second formula on your formula sheet, or although it probably says V plus V naught over 2, I can't remember. And I can never remember that one. You honestly, I don't think you're ever going to use that. What you are is you're going to use that one and the one that I wrote in black to get the next one, which is really, 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 really important. The one that we're going to flog to death. Oh, little nerd point, by the way. If we're talking uniform acceleration, this average occurs exactly halfway between the minimum and maximum velocities, which can sometimes be a nice shortcut if you're trying to do math in your head. You don't need to memorize that, though, because it's only a convenient shortcut, and it's not that good a shortcut. It saves you like 5 seconds. Meh. Distance. Distance is defined as average speed times time, or it's defined as that, but if I plug in the V average equation, I get that. Oh, and V final is VI plus AT. What that means is I can rewrite this whole mess as a big bracket, a big fraction bar, a 2 on the bottom, and a T outside the bracket. But instead of VF, I can write VI plus AT. And then there's another plus VI that was from the original bracket. Is that okay, Lewis? So far, so good? I notice, though, I have VI plus VI. What's 1 VI plus 1 VI? It's got like terms. So I could, if I wanted to, rewrite this as D equals 2 VI plus AT all over 2 times T. I don't like that T sitting outside the brackets, so Mac, I'm going to multiply the T into both of those and get rid of the brackets. I can actually rewrite this as 2 VIT plus AT squared all over 2. And hopefully, Addie, it might be starting to look a little familiar. I can see where you're going with this, Mr. Dueck, which is why the V average is so necessary. It's so I can derive this next one. You know what? Really, what I can do is I can break this fraction up. I'll do this on the next page. You can do this wherever you have room. This is really 2 VIT over 2 plus AT squared over 2. If I'm dividing the whole thing by 2, that's the same as dividing each one by 2. Is that okay, Carolyn? And the nice thing is, you may notice the 2's there cancel, and in fact, you can kind of see, oh, we have just derived D equals VIT plus a half AT squared. And we flogged that to death pretty good last year. How many of you have seen that one before? Physics 11's all I have, right? Good. Ta-da! Oh, lastly, we have this. VF squared equals VI squared plus 2AD. And again, I think on your formula sheet, it's V squared equals V0 squared plus 2AD. Hopefully you're comfortable just flip-flopping between the two notations in your head. This is also, there's a lovely derivation, but later on this year, when we get to energy, it's going to pop right out in front of our face. So I'll save the derivation till then. VF squared equals VI squared plus 2AD. This one's a little tougher to derive, but it pops up when we look at energy. Let's do some examples. I have a couple of acronyms, a couple of strategies that I give kids when we come to questions. I say when you come to a new question, if you're not sure what to do, you DULP and you DFIC. DFIC stands for list your data. I do that because just writing something down, Quinn, I've learned over the years, you feel better, you're more relaxed, scores go up because it's no longer blank. And I don't know why, but teenage brains, I've stopped trying to figure them out. The F stands for find a formula that has the things in your data in it. The N stands for insert the numbers, the data. And then the C stands for crunch or calculate the answers. I usually say crunch the answer out because it's less writing. So when in doubt, DFIC. And then the other thing that I use is DULP. Kids that had me last year, what does DULP stand for?
Draw a little picture.
Draw a little picture. When in doubt, DULP and DFIC. When in doubt, draw a little picture, list your data, find a formula, insert crunch. That'll bail you out of about 90% of what we're doing this year. That'll get you started. And my whole strategy is always, Jordan, I will always teach you how to start. I will always try and, the way I'm going to teach Physics 12, I try and give you cues to look for so you know, oh, this is, I can't call it a no-brainer because you have to know what you're doing, but it hopefully will become a no-brainer. Oh, if I see this kind of question, I always do this without even thinking, and then I derive the rest. So, I looked these numbers up online. I tried to make these accurate. A dragster has an acceleration of 18 meters per second squared, just shy of 2 Gs. It begins from rest. A, how fast will the dragster be going after 2.1 seconds? I always start out by saying, what's this question asking me to find? VF, and I write down VF equals question mark. You see, Justin, it's no longer blank. I feel better. Then I start to go through and I relist the data. I see that 18. What is that 18?
Acceleration.
How do you know it's an acceleration?
Square.
So as much as I hate memorizing, it is so worth memorizing what units go with what measurements. That totally cuts down on your thinking. I see a meters per second squared and I go, hey, that's an acceleration. Now, you can write meters per second squared next to the 18. You don't have to. I'm not going to make you. You can if you want. This is also a physicsy word that I always mentally or physically underline. The word rest or from rest. What's that telling me? What's zero? Then I see a 2.1 time. Then I would say to myself, I'm looking for an equation that has a VF, a VI, an A, and a T. I think this one we're starting off with a review of Physics 11, which seemed so tough at the time, but hopefully now this is almost a walk in the park. You would say to yourself, I think I want this equation here. And the VF is by itself already. Otherwise, Robbie, I would, in Physics 12, expect you, it is Rob, yeah? Robert. I got a Robbie in my other class. I would expect you to rearrange it in your head and just rattle it off to me with the variable by itself. In other words, if I was trying to find A, I would say to you, what's the equation? If you started to say VF equals, I'd say get the A by itself. Oh, A equals VF minus VI over T. Here, though, we can plug and chug. 0 plus 18 times 2.1. Can I do this in my head? 18 times 2 is 36. 18 times 0.1 is 1.8. 36 and 1. 37.8? Double check me. Yes? I can do math in my head. 37.8 what? Meters per second. How many sig figs have I just written? 2 or 3 is good. We're going to be very pragmatic. By the way, technically I should probably go to 2 because 18 has 2 and 2. It's on the provincial exam. They used to just say give everything to 2 or 3 sig figs. So I'm going to be very, let's go 2 or 3 sig figs. Oh yeah, there was until 2012, I think. Yep. You've got parts of it in your hand in that big ultimate assignment.
Why'd they cut it off?
Money. They didn't want to pay teachers to mark. The physics provincial was half written, and so it. Pause the video for an editorial. Okay, we'll do that. How far will it have traveled after 2.1 seconds? Did we just list our data in the previous question right above on the same page? Then, as far as I'm concerned, Carolyn, I don't need to re-defic. I'm just going to say, well, what are they asking me to find here? By the way, probably technically a displacement because I think we're in vector land, but whatever. I get distance and displacement mixed up all the time, and I'm never fussy on that. You'll also notice, I'm probably putting the vector thing there to remind myself when vectors really matter, in particular when we get to momentum, you're going to see me all of a sudden really emphasize the vectors again. Where we can just let up be positive and down be negative, I'll be a bit sloppy. Anyways, I'm looking for an equation that has a D in it. Oh, and has any of these. Why wouldn't I want to use this one? Don't write this down. That's got the D in it. Why, if I was a good test writer, would I not want to use that one? Colin.
In case you got the previous one wrong.
If I got VF wrong, I'm going to get this one wrong. Now, if this was a test and you got A wrong, but you used A to find B, I will give you full marks for part B, even though you got the wrong answer. Or, Quinn, if you're writing a test for me and you can't find A, blank him. Write a note, Mr. Dueck, I can't find V final. Make up a reasonable value. I'm going to make V final be 50 meters per second. By reasonable, like, don't go faster than light, or heck, for a dragster, don't make it 1,000 meters per second. They don't go with a reasonable value. And then just say, I'm going to use it to find part B. And I will give you full marks for part B. In other words, the only time I will get angry with a kid on a test is if they leave it blank. If they leave it blank. Then I'll get grumpy bear. Okay? Yeah, I would use this one. In fact, Riley, I would probably smile and do that. Or I might even skip writing that, and I might have just written D equals a half AT squared, because VI is 0. It's going to be 0.5 or 1/2 A 18 T squared. You get 39.7? Meters. And you'll notice I rounded off to 3 sig figs without even thinking about it. C. Are you guys turning the page? Okay, if we're turning the page, we may read DFIC. I don't know. We may relist our data. It says, how long will it take the dragster to reach a velocity of 126 meters per second? What's C asking me to find? Now, in English, how long is a tricky phrase because it can mean time. How long did it take? It can also mean distance. How long was the field? Sorry to my ESL students, but you'll hopefully just figure out the context. It'll be pretty obvious. So I'm going to go T equals question mark. And it looks like this time they've given me a V final of 126. Oh, I still know VI from the previous page. What was VI? 0. Can I use the T of 2.1? No, because it's going to be a different time. But let's assume the acceleration is constant, because Mr. Dueck said he'll do that, otherwise we need calculus. The acceleration was, I'm going from memory, was it 18? Looking for an equation that has a T in it, VF and a VI and an A. Get the A, T by itself, please.
T equals VF minus VI over A.
Yeah. You okay with that, Jose? We really, I know, to my new students, I don't know, but I know Mr. Kamosi and I really push doing this, and it's because we know this year it is such a time saver. Such a time saver. Which is going to be 126 minus 0. I probably didn't need to write the minus 0 all over 18. Can I do this one in my, oh, maybe I can. Divide by 3, it's going to be 42. Divide by 3 again, it's going to be 14. Divide by, is it 7 seconds even? Okay. So I'll go 7.0, 2 sig figs. I can do math in my head. How far will the dragster have traveled once it hits 153 meters per second? Okay. Now we've got a question again. What's that 153? Yeah. Acceleration. I've heard time. I've heard V. Which one, folks?
Yeah.
Meters per second. It's a velocity. Which one? V final. I think we can still assume V0 was 0, or V initial was 0. Do we know time? We could find, wait a minute. I know A is 18. I don't need to find time. I think there is an equation that has a D, a VI, a VF, and an A in it. And You didn't use that one much in Physics 11, the squared one, the squared one. You were going to use that actually an awful lot in Physics 12, it turns out. It's the VF squared equals VI squared plus 2AD, yeah? Can you get the D by itself? D equals, I think the VF squared would stay where it was. You would minus the VI squared over, and then divide the 2A. It's going to be 153 squared minus 0 squared to find where they are? Yeah? It's this one. Although I think on your sheet it's that, and I think there's a 0. Is that right, I think, on yours? Yeah. The squared one. Yeah. And then we got the D by itself, so I minus that over and divide by that, right? Don't worry, you'll get it. They've had lots of practice with this, so. More than one number on the top, brackets. More than one number in the bottom, brackets. So, bracket 153 squared minus. I guess I didn't need to type the 0 squared, Robert, but okay, it's there. Divided by. Do that one in your head, Mr. Dueck. My squareds and the hundreds aren't very good. Do we get 650.25? No. That's 5 sig figs. 650. That's 2 sig figs, but I can't go 3. When the dragster hits a top speed of 162 meters per second, the chute is deployed. If it takes 12 seconds for the dragster to come to a stop, what's its average acceleration? How long does it have to travel before it comes to a stop? You know what? Let's call, since I sensed 2 questions, let's call this part A. Let's call that part B. Gonna make it, kiddo? Because that's like your 5th yawn. I'll yell if I have to. So part A, what's part A asking me to find? Ironically, A says find A. Sure. All right. This is a new situation. Let's list our data again. Let's defic. What's that 162?
VI.
Ah, this time it's a VI, an initial velocity, or a V0 if you want to use that notation. I'm going to use I and F. So then what's V final?
0.
Stopped, 0. What else have they told me? Okay. I'm looking for an equation that has A, VI, VF, and T in it, and I'd love you to get the A by itself. I think this is our old friend. By the way, I see some of you turning back on the white page. Get used to glancing at the formula sheet, because that's what you'll have on the test, and you can actually train your eyes to look in the right location. I kid you not.
A equals VF minus VI.
It's going to be 100 and... Oop, careful, Mr. Dueck. It's going to be 0 minus 162. I'm going to get a negative answer. Oh, wait a minute. Am I slowing down or speeding up? So should I get a negative acceleration or a positive acceleration? The physics is telling me, actually, no, I'm okay. The answer is telling me I'm doing the physics right. I'm good with this. I'm not going to be worried about a negative. Should probably do that one in, oh, whatever. Negative 13.5. Units. Who remembers how big is 1g of acceleration? Negative 9.8. So this would be about a g and a half. You'd feel yourself being, you'd feel like you were being thrown forward. Okay. Oh, B. How far does it travel? How long does it have to travel? You know what? That almost sounds like time. The only reason I know that that's not asking me to find time is because they told me time in the question, 12 seconds. So I will assume, even though this is worded kind of vaguely, that this time, how long refers to a displacement. Are we still on the same page? Then I'm not going to re-defic everything, and we're still part of the same question. It's all up there in part A. But I am looking for an equation that's got a D. Now, what grade are we in? In Physics 11, because people were still somewhat rookies with their calculator and crunching stuff, I really tended to avoid using an answer to find an answer. Although Colin, I talked about it earlier, I hardly worry about it in Physics 12. So you know what? I'm going to use this. Even though I'm going to use the A from part A, because it's so convenient. It's just sitting there. I got the D by itself. It's less. I'm in. It's going to be 162 times 12 plus 0.5 negative 13.5 12 squared. Had we been in Physics 11, we would have used the one, there was one equation that had VF, VI, D, and T. It was the one that was VI plus VF over 2 to, I don't know. I'm going to use stuff that I found with confidence now. What do you get? $972, just shy of a kilometer. I Googled these numbers. Now, how accurate Wikipedia is on dragsters, I don't know, but these are reasonably accurate. Takes about a kilometer for them to come to a stop. Top speed of a dragster, around 160 miles an hour. That's about 290 miles an hour, give or take. Sorry, 160 meters per second was around 270, 280 miles an hour. So about there. Turn the page. You're going to see a lot this year. I'm going to be giving you what I call, Quinn, using principles of physics explain questions. On your test, you're going to get some as well. You're going to see them in the big review package. You're going to see them in the homework. And here's our first one. It says this. An object starts at rest. You know what? I would probably underline the word at rest because that's always important. And accelerates east at a constant rate. When it has traveled 10 meters, it's moving at speed v. How fast will it be moving when it has traveled 20 meters? Select the best answer. A, v. B, more than 2v. C, 2v. Or D, less than 2v but more than D. Here's what we're going to do. Pause the video. You have to vote. So now I've explained the voting. A, no one. Who says, gotta be B? Okay, keep your hands. 1, 2, 3, 4, 5. A latecomer, 6. Ooh, peer pressure, 7. Who says, nah, C? 1, 2, 3, 4, 5, 6, 7, 8. I think I saw 9. Who says D? 1, 2, 3. Someone didn't vote. I'll get him next time. Explain your answer using print. Convince me. So then I always say you can either attack someone else's answer as being wrong or defend your answer as being right. Attack or defend? Anybody? Convince me. Colin. What did you pick?
I picked B.
B? Okay, convince me.
So I feel like the acceleration is constant, and that's the change in velocity. So more changing would have happened.
I lost him.
Yeah, I don't know.
Okay? Now, you will get good at these. In fact, by the end of the year, most of you will be able to do these algebraically with lovely proofs. In fact, generally, I usually say the less English, the better the proof. Often we'll draw a free body diagram or a good picture. But to start out, I will always say a good start is to make up reasonable numbers and crunch it. So it says when it has traveled 10 meters, it's moving at speed v. Let's make up a reasonable speed. And by reasonable, I wouldn't use 17, a prime yucky number, or 36.2. What's a nice speed v that would be happy to do some math with?
5.
Don't even like 5 is, let's go 10. You know, the only reason I'm not going to use 10 is there's a 10 in the question, and we're all getting mixed up. I'm going to go 12. Why 12? Because lots of stuff goes into 12. 2, 3, 4, everything but 5. So I'm going to say this. Suppose, oh, first time this year, my pen has stopped working. What's going on? It's been going good. Okay, we're back. I'll let V be 12. What was D? 10 meters. What was VI? Couldn't we find A? Well, let's do that. A equals, what equation has a VF, a VI, a D, and the squared one? Can you get the A by itself? VF squared minus VI squared, yeah? All over 2D. Because if I can figure out A, then I can just crunch this and convince myself. Also, by looking at the equation, I may even already be able to see how everything's going to relate together. Let's see, it's going to be 12 squared minus 0 squared, haha, equals 2D. Oh, 2 times 10. It's going to be 144 divided by 20, right? Which is going to be 72 divided by 7.2. Yeah. Well, now I could go VF squared equals VI squared plus 2AD, and I can say we're starting at rest. A is 7.2, and D is 20 meters. Oh, except this gets you VF what? So I'll square root at the end. 2 times 7.2 times 20. Are we twice as fast?
More than less.
What was our initial guess for V? 12. Twice as fast would be what? 24. More than would be what? Did I make a mistake? I think I'm right, yes? That's right. And now, okay, so first of all, those three of you, well played, I say, well played. And now I can look at this, and I think that squared that I circled in red is actually the mathematical answer to this whole thing. Even if you double the distance, you're going to square root at the very, very end, so you're not going to get twice as big. Right? See, now I've actually inadvertently made an algebraic proof, and now I kind of smile and say, if I wanted to, I could answer this algebraically. But Tyler, I'm fine if we just tackle it with numbers. It says, explain your answer using appropriate principles of physics. There, we did. We crunched reasonable numbers. But you're going to find, as the year progresses, Tamara, there's going to be some that I'm going to do totally algebraically, and your little math nerd heart is going to go, boy, that's pretty cool. 4 lines, no English, that's a nice proof. But for all of these, I have no problem if, as your fallback, Isaac, you can always make up reasonable numbers, crunch the numbers, and prove it to me. I'm good with that. Okay. They used to, we'll go back full circle, Mac, on the provincial exam, the last question on the written was always a using principles of physics right to explain question, and there was always one more somewhere in the written as a part B to a part 1 as well. They always had 2. I called them essay questions. They're not essay because I use as little English as possible, but this is very good wrapping your brain around what we're talking about stuff. Next page. One more, we're done. Yay! Two cars are at rest. You know what? I have a habit. Anytime I see that phrase, I tend to underline it. Also, because I've written something down, I feel better. I'm not nervous. Facing each other and 300 meters apart. If car 1 accelerates at 6 meters per second squared up to a maximum speed of 30 meters per second, and car 2 accelerates at 5 meters per second squared up to a maximum speed of 35 meters per second, how long does it take the cars to meet? Now in Physics 11 we looked at something like this. We called it relative velocity. But Lewis, in Physics 11 we kept everything at a constant speed. We had no acceleration. Welcome to Physics 12. Any thoughts here? By the way, this is a tough question. I would consider this probably an A-, A-level question. This is a tough question. Do you remember what I said was the only thing that would make me angry if someone leaves a question what? Blank. So a lot of my strategy for you guys is ways to work around it. You know what? Are there 2 vehicles? First thing I think I would do is that. I've written something down and I've just realized, I'm going to try figuring out whatever I can about vehicle 1. I'm going to figure out whatever I can about vehicle 2. And I think somewhere along the way, Jake, if I'm going to have them crash, I think what I'm going to be saying is mathematically something is going to be equal to something else. What's going to be equal if they crash? I think... Yeah.
Does how long mean the time or
I think time. I don't know if I don't know if they're going to be going at the same speed when they hit. It's so obvious. It's tricky. And we're going to solve for time. How are we going to solve for time? There's something else that will be the same. D, their position. Not their position, their position relative to that 300 meter apart. I think what I'm going to try and do is come up with a mathematical expression for car 1's distance traveled, come up with a mathematical expression for car 2's distance traveled, and let them equal to each other. That's when they hit. Doesn't mean it's going to be 150 meters in the. It's going to be when they're at this. I think we can do this. I didn't do this question last year. I stuck it in this summer. We'll see how tough this is. This may be beyond what we can handle. We're going to try. You know what I'm going to do first? I'm going to defic. A equals 6. VF equals 30. VI equals 0. A equals 5. VF equals 35. VI equals 0. You know what? After writing that out, I've decided to change my strategy. I think you were right. I think time is going to be the same for both of them on impact. So I think what I'm going to try and do is write an expression for time for each of them. Maybe that includes a distance in it, and let the times equal each other, I hope. Let's see. I mean, certainly I can say this. Oh, wait a minute, wait a minute, wait a minute. We got a problem here. We got a problem here. How long does it take this guy to hit his maximum speed? Well, if I go t equals vf minus vi, 5 seconds? And then, huh? So that means for 2 seconds, car 1 is going to be going at a constant speed. Yeah? Okay, this is enough though. I can figure. Maybe we'll see. How far does this guy travel in 7 seconds? It's going to be vi t, 0, plus a half a 7 squared. So he hasn't gone halfway yet. So once he gets to his top speed, he's going to keep going. Is that right? You okay with that, Tyler? Okay. How far does this guy travel in the first 5 seconds? 75? Someone crunched it already? And then, how far does this guy travel in the first 7 seconds? It's going to be 75. And now we're going at a constant speed. What's the constant speed? 30. How many seconds? 2. What's 75 plus 30 times 2? Ah, this is good, this is good. 135? Even? All right. So here's what I think. Go! Tick, 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 tick. In 7 seconds, how far does this guy travel? In 7 seconds, how far does car 1 travel? 135. In 7 seconds, how far does car 2 travel? Right? Yes? Ah. First, I'd like to know what's left. How far apart are they after 7 seconds?
257.5.
Please do the math. Yeah. It's going to be 300.
42.5.
Take away 135. Take away 122.5. Okay, now we have 42.5 meters left to cover. Jordan, you okay with that? Yeah. And are they accelerating anymore? Ah! Lewis, we've turned it into physics 11 relative velocity because now it's a constant speed. Now what we have is this. 42.5 meters. How fast is car 1 traveling? 30. How fast is car 2 traveling? How did we solve these when there was no acceleration last year? Do you remember our trick? We actually just said pretend one car is standing still and pretend the other one is traveling at 65 meters per second. The combined velocities. Right? We said this. The relative velocity is 65 meters per second. A is 0 now. Distance is 42.5. Can I find time? I left you guys a whole page, yeah? Yeah, good. Well, a whole half page, but yeah, full page. Can I find time? Sure, I can use d equals VIT plus a half AT squared, except it's just going to be d equals VIT, the half AT, a is 0. It's just going to be the time after they reach each of them, their maximum speed is going to be distance divided by the combined relative velocity. It's going to be 42.5 divided by 65 to each other. I'm pretending one car's standing still and the other one's coming in at 65. I could go 130 and 135. That's keeping track of two vehicles. I'll just pretend car A is temporarily frozen. Car 2 is coming at 65 meters per second. Same math.
Okay.
Is that okay? It's going to be divided by 65. That takes 0.653 that many seconds. 0.6538. Mr. Dueck, that's 4 sig figs. Is this my final answer yet? I'm going to carry as many extra sig figs as I can. In fact, I'm going to use the answer button on my calculator. All right. So what does that mean? Total time. Let's look at, oh heck, car A. You know what? Let's look at car B. Car B is nicer. Car B traveled for 7 seconds. And then, how long did it take after those 7 seconds for the collision to occur? Another 0.65. It's going to take 7.65 seconds for them to crash. How long did it take the cars to meet? 7.65 seconds. Although it says assume they're in different lanes so there is no crash. Oh heck, let's just pretend it's a crash. That's funner. That's just to let you know, Quinn, what we can do by thinking out of the box, by not panicking, by defic, by, you notice I drew a little picture, I dolloped right there as well. What I'm going to be, and the phrase you're going to hear me say this year, Faizan, is I'm going to be stubborn and clever. Stubborn and clever. Stubborn, I'm not going to quit. I hate leaving stuff blank. I'm going to write something down. Clever, okay, now what? If I can give you all one skill this year, because how many of you are going to post-secondary next year? Okay. If I can give you one skill this year, most of you have never had to deal with, what do I do if I don't know what to do? If I can give you one skill this year, I want to try and give you situations where you don't know what to do. Now what? 2 words. Stubborn and clever. That'll get you through a lot. What's your homework? Number 1 is good. Number 2 is good. Oh, bungee jumper. 4, skip 3. 6 is good. I skipped 5. 7 we actually did in our homework, didn't we? Prove that D equals, so, okay. I'm looking at number 10. Oh, 200 meters apart. The distance was different. I was going, why is number 10 a different answer? I'm going to say you can try number 10. I'm going to put a star. When I put a star next to something, what I'm saying is this is tougher than I'll ask you on the test. Okay? Try number 11. Ten minutes, well, 12 minutes left. That's plenty. This is review. That'll jog your memory.